Hello everyone. Today I want to introduce how to apply the basic digital signal processing techniques on digital image processing. First of all, I want to say thank you to Dr. David Durant who supported me for finishing this project. My presentation will include several parts. The first part, I will talk about the image enhancement. The second one will be the ad detection. And the final, I will represent my application I created. Image enhancement is a basic idea to provide better presentation of a digital image, which could be implemented on the spatial and frequency domain as well. Smoothing could be understood as a low-pass filter that only allows the pixel which had intensity is below the threshold. In the spatial domain, I use a median filter. This filter will reduce the noise. And as you can see in the array here, the pixel have an abnormal values will be filtered. By arranging the pixel at a numerical order, the filter will choose the middle value for reflecting for the noise. In frequency domain, Gaussian transform function will be used as a low-pass filter. First of all, the image will be converted by using a Fourier transform. After that, it will multiply with the Gaussian smoothing function, and then being inverted to the spatial domain by EFFT function. Sharpening is opposite to the smoothing. Sharpening could be understood as a high-pass filter that only allows the pixel which has the intensity larger than the threshold. In the spatial domain, I use unsharp masking for the sharpening filter. The whole idea of this filter is to extract the output without the smoothing components. In the frequency domain, I use a Gaussian transform function. The procedure is look like the procedure I use in the smoothing, but the difference here is a filter. As you can see, the filter here is a high-pass filter, it's not a low-pass filter. Therefore, I have a new image, I have a new output. In the second part of presentation, I will introduce you about ad detection. Ad detection is also the basic idea in the object recognition. However, you first should understand what is an ad. Ad is defined as an abrupt trend in the value of intensity. As you can see here, that is an abrupt trend from the low component frequency to the high frequency, after that to the low frequency again. By using the first derivative, you can find the location of the edge. I list several basic steps here. However, if you want to figure out in detail, please see the link I insert in the video. To be simply, I will show you a demo by using my application I already created here. In the main window interface, you can choose the input by clicking borrow button here. After insert the input image, you can choose the technique I providing here. It depends on each kind of technique. The threshold level box and the FFT function box, FFT dimension box will be enabled or not. In this example, I will choose the ad detection and left the default value here, and let's see what happened. I click on the apply button. The application have one mate that should insert the suitable dimension for the FFT function, and this value should larger than 1700. I will insert around 1800 and click apply again. Yes, I got the new output here. I got an output with the highlight the add. And you can see the add around the letter and the add around the logo has already been emphasis on. So after my presentation, I hope you can get a better view about how to apply the display technique on a real application. Thank you for your attention today.